Okay, so in this video we're going to give a recursive definition of the reversal of a string. So what we'll do is we'll start with some definitions here. I'm going to define, I have two sets here. I have a set in pink. I have a set in pink that contains strings. Okay, so this is a set of strings here, and I'm going to use the submission star to denote the set of strings. Then what I have over here is a second set. Is a set of summations, which is basically my alphabets. So if my alphabets, so think of this way: if I take any item from this set over here, and let's call this omega. What it means is that the length of this omega will be 1. Okay, so if I have function L, that's the length. The length of this is going to be equal to 1 because it basically contains just a character. A character is basically when you take these characters and when you perform some kind of a permutation of these characters, what you end up creating is a string. Okay, so as a concrete example, if I say that this set contains only 1 and 0, it's a set. A summation is a set that contains 1 and 0, and if I take the following combination, of 1 followed by concatenated with a 0, I have a string now which is 1 0. I can take 1, concatenate it with 1 again, and I've created another string 1 1. And I can keep on doing this. I can keep on creating many different strings over here, which will all be concatenation of various kinds of some other substrings, and the character in these strings are all going to be the characters that are present from this yellow set. Okay, so if I choose any w from the set pink, this w is going to belong in summation star. And if I choose any omega from this yellow set, this omega of length 1 is going to belong in my summation. Okay, now the question is, give a recursive definition of a reversal of a string. So because I need the recursive definition, I need to have two cases here. I need to have something which is my bases, and I need to have something that happens to be the recursive part. So what I'm going to say is, alright, for the bases, I'm going to say that the reversal, let's call this function R, the reversal of omega is going to be omega, because if I take a character, if I just take any character and I try to reverse that, the reversal of the character is just the character itself, and that's the basis part of my definition of the reversal of a string. So these two combined together is going to be the definition of the reversal of string. And this R over here, I'm using the subscript R to define my function. Okay, now what is the recursive definition here? The recursive definition over here is, I'm just going to use a slightly different color. The recursive definition over here is that the reversal of my string w, of this w that I choose from the set pink, is equal to R of w prime followed by some omega. Now what does that mean? This means that w, the string w, is a concatenation of some string w prime followed by omega. So let's define these variables. The moment you use a variable in your expression, you need to define them. So again, w is some string that belongs in summation star. W prime is some string that belongs in summation star, and omega over here is some character that belongs in summation. And again, let me give you a concrete example. So if I think of my string w as, let's say, 1011, then what it means is this w is the concatenation of w prime followed by omega. So w prime is going to be 101, and this omega over here is just going to be 1. And when I concatenate 101 with 1, I get back 1011, which is what w is. Okay, so the reversal of the string w, which is the concatenation of w prime followed by omega, is also saying the reversal of w prime followed by omega. Okay, so what is the reversal of this piece here? Well, the reversal of this piece is the reversal of 1011. I can see from this example that the reversal of 1011 is I take the last character and bring it as the very first. Okay, so I take the last character, bring it as the very first. So the reversal of omega prime followed by w prime followed by omega is going to be equal to omega concatenated with whatever is the reversal of w prime followed by the reversal of w prime. Okay, so I take this one which is over here. Now what's remaining is 101, but I cannot concatenate 1 with 101. That is incorrect. What I want to concatenate is with the reversal of 101. Okay, so when you reverse 101, whatever that thing is, it just happens to be the same, because in this case it's a palindrome 101, and if I look at the reversal of 101, it's also 101. But what I really want is the string that is remaining. I need to take the reversal of that, and that is basically what happens to be concatenated with this omega, and that is the actual recursive definition. And again, with recursion, the key here is that when I call recursion again, you call recursion on a smaller problem size. So if this w happens to be of size n, the length happens to be of size n, and this is where I'm using this property. I'm using this property that was given to you as a hint. If w happens to be a string of length n, then it's obvious that the reversal, which is the recursion function, is working on w prime, and w prime is also a string that happens to be of length n minus 1. That is because I have stripped away the character omega. So omega has been taken off. So whatever remains in w, which is w prime, is going to be 1 shorter than w. So it's going to be of length n minus 1. And when I keep on calling recursion over and over again, I start with n, I then work with the problem as n minus 1, at some point I'll work with n minus 2, then work with n minus 3. I keep on doing this until I hit some value, n minus I, where this n minus I can be solved without recursion. And what would that be? What would this box be? Well, this box must be equal to of length 1. Because when it equals to of length 1, I know I can solve it without using recursion, which is my string of length 1. So when this box, which is n minus I, when n minus I equals to 1, I know that I can solve the reversal of the string without using any recursion.